I just don't get it. Why is it so slow? I'm just trying to multiply these lists.
Python lists? Yeah, they're not built for that kind of thing. Think of them like regular grocery lists. Good for keeping track of what you need, not so good for advanced calculus.
So what am I supposed to use?
NumPy. It's the backbone of scientific computing in Python. It's got these things called arrays. Yeah, think of them as supercharged lists. You can do all sorts of crazy fast calculations with them.
Like what?
Like multiplying every number in the array by 5 all at once. No loops needed.
Seriously?
Seriously, watch. First you gotta import it. Import NumPy as NP.
Okay, imported. Now what?
Now, instead of using your regular Python list, you create a NumPy array. Then you can just multiply the whole thing.
It's not just cleaner, it's way faster. Like if you're dealing with thousands of numbers, NumPy can do it in microseconds. Python lists would take milliseconds or even longer. Okay, I think I'm starting to get it. So NumPy is like the Flash for math?
Exactly, the flash for math.
So NumPy is the Flash for math. Got it. But what about like actual data? Names, addresses, messy stuff?
That's where Pandas comes in. Think of it as Excel on steroids.
Seriously?
Seriously. It lets you work with these things called series, like a single column of data, and data frames, which are like entire spreadsheets.
So I can finally ditch Excel?
Pretty much. The cool thing is how Pandas handles real-world data. Missing values, different data types, all that junk.
Okay, that sounds useful.
Let's say you have a file with customer info. You can load it with one line, pd.readcsv customers CSV. Boom.
Whoa.
And then say you want to find all the customers from, I don't know, California. A simple filter, and you're done. Average purchase amounts by age group. Pandas can group all that for you.
So it's like superpowered data sorting.
Exactly. NumPy is the Flash, Pandas is the Swiss Army knife.
Okay, I think I'm getting the gist. Flash for math, Swiss Army knife for data. What's next? Making pretty pictures.
You read my mind. This is where the visualization libraries come in.
Visualization? Like charts and graphs?
Exactly. First up, Matplotlib. It's the grandfather of Python visualization.
Grandfather?
It's been around forever, and it's the foundation for everything else. Think of it as your digital artist's toolkit. Simple line plots, complex statistical visualizations, it can do it all.
Okay, so I have sales data and I want to see the trend over time.
plt.plot and you're done. Comparing categories, clear professional charts, easy as pie.
All right, I'm sold. But what if I want something fancier?
That's where Seaborn comes in. It builds on top of Matplotlib, adding statistical visualization. It's like having a statistical expert who knows exactly how to present your data.
A statistical expert?
Yeah, heat maps showing correlations between variables, distribution plots that reveal patterns, all with just a few lines of code.
So fancy pictures are cool, but what if the data is a mess?
Ah yes, data cleaning, the unsung hero of AI.
Cleaning, like dusting off numbers?
More like surgery. Missing values, funky formats, outliers trying to ruin everything. It's usually the most time-consuming part, but you gotta do it right.
Sounds.
All right, let's talk practical data prep. First things first, data exploration. Think of it as getting to know your data before you start rearranging the furniture.
Exploration? Sounds like I need a map and a compass.
Pandas is your map. Use .info, tells you the data types, column names, missing values, the whole shebang. And .describe gives you the stats, mean, median, standard deviation.
Missing values? That sounds ominous, like finding holes in my spreadsheet.
Exactly. Pandas has .fillNA. You can fill those holes with zeros, the average, whatever makes sense for your data.
Okay, holes plugged. What else is lurking in the shadows?
Categorical variables, text basically, machine learning models like numbers, not words.
So I can't just tell it red is better than blue.
Not directly. You gotta encode them. One-hot encoding is your friend here. Turns categories into columns of ones and zeros.
One-hot encoding sounds a bit intense, like turning my data into a binary battlefield. So ones and zeros. Got it. Anything else trying to sneak past my defenses?
Outliers, the rebels of the data world, values way outside the norm.
Outliers? Like a house that costs $10 million in a neighborhood where everything else is under a million.
Exactly. They can skew your model, throw everything off. Box plots are your friend here. Matplotlib, Seaborn, boom, outliers visualized. See those points hanging out way beyond the whiskers?
Yeah, they look pretty far out there. So I just delete them?
Not necessarily. Sometimes they're errors, yeah? But sometimes they're telling you something real. Maybe that expensive house is actually there, and it's important information. Gotta investigate.
Okay, so interrogate the outliers. Got it. What's next?
Feature scaling. Imagine you're comparing kilometers and inches.
Yeah, that's apples and oranges.
Exactly. Machine learning algorithms, like everything on the same scale. So you gotta scale those features.
Scale them, like shrink them down.
Or blow them up, relatively speaking. NumPy's got your back. np.mean, standardize everything. Or Scikit-Learn's pre-processing module has even fancier methods.